This is from a 94 Magna, Honda Magna, and it has similar problems with a broken tip in the slow screw down deep inside here, as you've seen in other Valkyrie repair videos.
And also on the ZRX 1200, that CVK carb.
And I did the same basic operations, and I'm kind of picking this project up midstream. I'm not starting from the beginning, where I've already pressurized the system to try to pop that screw tip out, which didn't work. And I've already machined out this plug right here, and that is unfortunately no bueno as far as reaching up with that little tool I made to pop that tip out. This sucker is really mashed in here. So the only option I have left is to machine it out with those micro bits like I did on another carburetor. Now the challenge we have here is quite obvious. This standoff for the slow screw or the pilot screw is not perpendicular to this surface, so I can't indicate this surface in. It's at an angle, and I do not know the angle. And I don't have really good reference, surfaces, machine surfaces, to try to indicate off of. The best thing to indicate off of would be the standoff, but that's just part of a casting and it's not machined. What am I going to do? That's why I'm filming this, because I'm going to try something I've never done before. We're going to make a tool and thread it in the lathe for metric for this thread inside this bore, and it'll stick up high enough and it'll seat down in the bottom there that has a little chamfer, and hopefully it'll be close enough where we can get this thing trammed in on the Z-axis for both X and Y. In other words, going up and down, so it's not cocked that way and it's not cocked that way, or it's not cocked one way or the other. It's got to be straight up and down. Fixturing's not terrible here because we can just use features of the outside of the carburetor with a block like I have here.
Because of these challenges, I went ahead and ordered this tilt table for my mill. It's not in this video, but it will be in upcoming videos to do more carb work.
It's going to be fixtured well enough to do what we got to do once we get it trammed in, if we can get it trammed in. And I've never done that on a thread like this. I thought I'd bring you along. All right, so the first thing I did was I found a slow screw, and you've seen these before, or a pilot screw, that is the right thread for these. It's not the right screw, but it's the right thread. That's all that matters. And my initial idea was to just put it in upside down, let it stick out the top, put it down a certain amount. The thread's in just fine. Then indicate off that and also get the concentricity of the hole. But it just wiggles around too much. See if we can demonstrate that. Yeah, you can see how it's wiggling around. It probably would be okay, but since those micro drills are extremely close to the major or maximum diameter of that little tiny hole in which that tip is broken off in, I really don't have wiggle room. Little pun there, wiggle room. I don't have it. So that's my idea for making a tool that goes down further and seats down in there. That'll essentially lock it in and theoretically down perfectly concentric and in line, parallel with this the standoff and that hole that's drilled and tapped in there for this type of a screw. That's in theory, because again, I've never done this before, but this is kind of the genesis of the idea. When I came up with it, I said, why can't I just put a screw in upside down? And if the threads are a little bit tighter, and I tried various screws that I still have, they're all about the same, and they all have that same kind of wobble. Not good enough. So what I did was I measured this thread with the thread pitch gauge, which ain't the easiest thing to do with my eyes. And I came up with that this is a 0.5 millimeter thread pitch. You measure the OD and I forgot what it is. I think it's like M6. But we're going to have to set the lathe up to cut a 0.5 thread pitch, which I've never done before again, but I do have the gearing for it. Take you over to the lathe and we'll see if we can get that set up and then maybe make a test cut or something. I don't know. According to the thread chart that's on the cover that was right here that I removed, I need to do a couple of gear changes. This one's got to be flipped where this big idler is on the inside lined up with the gears. This is your main drive right off of the spindle, and as far as the power coming off, when the spindle turns, this turns. Obviously we have belts back there. That goes in some counter shaft, turn the spindle, and likewise it goes down to here to turn this. So this is your main drive for your feeds and as far as threading and so forth, because there's the counter shaft for that down here that goes into the gearbox. And then up here we need to put a, what do we got to put up there? We got to put a 20, yes, we got to put a 26, I'm looking down at the chart now. We got to put a 26 tooth up here, and we got to put a 60 tooth down here. I hope they fit. I think there's enough room on the banjo to slide these around. This guy in here is called a banjo because it looks like a banjo. Once you loosen this crap up, the thing swings around. You can move this gear set, kind of idler gear set, in and out to accommodate for the different sizes of gears, whether it be here or here. So we're actually putting a smaller one up here and a larger one down here. Just move this over to accommodate and make sure we got the proper lash. All that'll do off camera, so we'll come back when that's done. As is tradition, we face it and we put a center drill in for a live center.
A little shout out to Quinn from Blondie Hacks right there.
Now here is that slow screw that I was just showing you upside down before. So luckily this is just under 250 Imperial, which I think is 6 or 6 mil rather. So this is at 231 or so. I'm going to make it about 235. I'm going to make a little, maybe 233. I'm going to make it a little bit bigger. And I was going to mention, and I'm going to mention now, that typically when you do an external thread and you single point it, you have some sort of a nut to test it with, you know, besides the nut behind the lathe. So this is what we're going to use for our nut. We are going to use the old Valkyrie carb, the one that I did all that machining on kind of as an experiment. And I learned some stuff on this carb regarding this plug, which if we have time, I'll tell you about later, because this might be very important if you're going to do this kind of work and replug that particular spot above those transition holes. But that's for later on. But this is the same exact thread because it's almost the same carb body, and then see if it's going to work. Because down inside there you can see it's the same geometry, same profile. My objective is, on this end that we're threading.
Yeah, I screwed this up in live filming. Let me clarify. We're going to machine the end of this brass to match that chamfer at the bottom of the hole. Gives us the highest likelihood that this thing seats solid and is completely concentric.
So we'll take her down a little bit. This is at 250 now, so we only got to go a little bit. My objective is to thread, I don't know, so far, then pull out, and then we're going to end up cutting some relief on the front of it to get down to that chamfer in there, and maybe even some behind it, I don't know. But as long as the part sticking out is true and parallel and no tapers or anything, we're going to be crapping in high cotton here, I think. 33, let's leave it there. I'll go get set up for threading. We're going to have to make some assumptions on this, that it is a 60-degree thread, like a traditional thread is, although a very fine thread. So I have the sharpest or the least nose radius threading tool that I own in the tool holder now. This is not this isn't any positive rake at all. It's a negative rake, close to a neutral. I don't really want to use a positive rake on brass. It's so soft, it'll try to grab it and pull the tool in. So this is probably the best one for it. I've already touched off. Change the gearing around here, make sure we're in the right setting for this. On the metric chart, for those gears that we put in, for a 0.5, we need to be in C5. 1, 2, 3, 4, 5. And then we'll put her over into threading. I think we'll do 360 RPM on this. This is kind of a new territory for me on these very fine metric threads, so I'm kind of guessing on this one. Because we got to leave it engaged. Now I don't have any shoulder to go up against. There is a way to do this where you can disengage even in metric threads on an imperial lathe and not lose your, synchronization. There, I butchered that. This is not the video to show you that. And we're not going to use a compound because it's a fine thread, so we'll just go in with the cross slide. From what I can tell on the interwebs, I think I need to go in about 12 thou on a side. Total of about 23, 24 for an average thread depth as far as the pitch diameter goes. And I don't know if I have the clearance here. I'm really, really close to that live center right now. If we have to pull the center out, we have to pull the center out. But I'm going to try it like this. So I'm just taking 5 thou on the side right now, a total of 10. Ready to go. Whoops, no we're not. Dummy. I'm slowing that down to 270 because I'm chicken. There's a total of 20 right now. See what happens. I really would like to come back further because of the lash. I may have just completely smoked those threads because of the lash.
Every lead screw has some backlash. Here's a vivid example on an indicator, and it needs to be considered in threading.
I'm not going to be able to do it with the center, unfortunately. We're going to have to back the center off, and that way I can come back further. But it is what it is. Like somewhere back here. Let's chase those.
Hopes and dreams are the only thing keeping that part from deflecting under these conditions. You can see the part is deflecting. I was kind of afraid it would do that, and it's pretty evident that it's pretty much scrapped now.
I don't know. This doesn't look like it's going to work out. We're going to do this over. It's a do-over. So I've got a new piece in. I machined this down about 3/4 thou bigger than that last one because I did try that piece into the test carb. It does thread in somewhat, but it's very loose. So I'm going to keep that major diameter a little bigger. And this is 30 thousandths relief cut. We're going to come back into this space. It gives us about a 1/2 inch of leeway to reset the tool and take up the lash, and then we'll cut threads down here. We can always cut this off and do whatever we want with it later on. That way we can maintain the center. Let's try it again. I'm already touched off, and I'm in the same mode as far as gearing goes. Come back here so we have room for that backlash to be taken out. And come on. Now we're in. That's where it stays. Now, of course, without any threads out here, there's really no way to test it. So I'm going to kind of wing that. It does look better.
What I should have done was use some Dykem blue so I can actually see the threads being cut.
All right, I'm going to whittle away at this and we'll come back. All right, so here's our nut, besides the one behind the lathe. Here's our tool. I went 11 thousandths on the side for the infeed for a total of 22 for the pitch diameter. And let me tell you what, that is about perfect. With a larger major diameter of the piece. Now I haven't finished this end yet, and nor have I done that little angle, which I'm going to do that chamfer now so it kind of seats better. And we'll try it on the other carb. I just hit this with a file just to deburr it after using the hacksaw. Well, I'm going to do this end first so it sits in the chuck straight. I'll do that off camera. I'm just going to chuck it up this way. Just match that. It's going to be close enough. I mean, will it be out around a little bit? Yeah, probably. But I can always check it with the indicator. But, I mean, I'm not really trying to overcomplicate things. I mean, when do I ever do that? I'm just going to get it to the point where I think it's finished, and then we'll come back and show you how it goes in the other carburetor. And maybe we can move on and actually use the damn thing. I cut it at 60 degree because... Is that cut all the way? Nope. Let's try that again. I cut it at 60 degrees because I figure in this hole here they probably used a 118 degree included angle drill bit, to, I should say the tap drill size, for the threads that we just cut externally here, this M6 by 0.5. That's what it looks like at the bottom. So that's what we're going to go with. And she goes in nice and firm. Hopefully it does on the other carb, because it should be the same. And then it bottoms out pretty suddenly, so I think we're right up against that little chamfer in there, that countersink. It's going to work. So let's install it in the other carb. Alright, I made 2 changes to this tool before I used it. I had to cut some relief here on the end because the threads don't go all the way down. And so what it was doing, it was bottoming on the threads. I needed to bottom on that little chamfer, so now it does. On this carb and the test carb. And I filed a flat on the ends. That way I could use a 3/16 ignition wrench. So I can give it a little nip, as y'all say, and down under and over wherever. So you nip it up a little bit. and that worked out really well. So I indicated the tram as far as up and down on both axes, on the X and the Y axis, with the roto dial. That was a little fiddly. I had to shim this thing up in a couple of places, but I got it within 2 thou or so. It's as close as it's going to get. And then I did the concentricity. I tried to use the last word on this thing when it was in place. This indicator is just giving me trouble, so I may have to send it out to Stare to maybe just go buy another one off eBay, because I do like the last word. It's kind of gummed up or something. I ultimately just went right into the bore like I typically do with the Brown and Sharp and got that all trammed in 0-0. I don't really like the fixturing on this all that much compared to what I do on a different carb, where this is perpendicular to the surface of the float bowl. But it's the best I can do. The risk-benefit ratio is in my favor because there really isn't any risk. Because the carb is unusable now. If we screw it up, it remains unusable. But if we fix it, the benefit's all on my side of the scale. So we're going to ram this number 72 micro drill down through. It's glued in just like it was on the other video. I'm as centered as I'm going to get, and we'll just go nice and easy. This is where I really need that sensitive drill chuck, and I ain't got one. So this one, I can see it come through inside the hole that I opened up by taking that plug out. That's one nice thing about it. What I don't know is if these flutes of this drill are deep enough to get down all the way without the wider part of the drill flutes screwing up the aluminum as it heads down. So I'm going to start plunging this thing in very gently, and as soon as we see some evidence of it breaking through, that'll be it. Hopefully it's not too deep. One of these things where you're just kind of winging it, because that's the only thing we can do. Ramp her up. Aha, I see it. All right. What I saw first was a little of that W40 sneak down through there. And I said, ha ha. It's hard to tell. I think I see a hint of brass still.
Looks like a little ring or a sleeve.
All right, there's no point in putting this back in. The rest of it I'm going to do off camera, and I'm going to do it by hand with some of the other drill bits. I only have the 72s, the 70s, and the 71s. I do not know what the nominal size is, but I'm pretty sure this is the smallest one. The 72 is smaller than that, but like I said, I'm pretty sure I see a little brass around there. I'm going to very carefully go in with the 71, and then maybe even the 70 by hand, like I said, and then we'll come back, take a look at it. But there's no sense in leaving it in the machine because we don't need to do that by under power. Now this is something you don't see every day. Now take a look at this drill bit. Right there, under zoom, there's a little core or a sleeve of this brass around that drill bit. Now that's dead freaking center.
Well, almost. You can see it's a little thin on one side, and if you look at this picture again, you can see that we were just off center slightly, but we're not into the aluminum.
This thing may have been off just a couple of thou, 10 thou. We'll take a look at the carb hole. So that's what I thought. I saw something down in there. So that's just kind of an experience too. The hole didn't look the right size. So there you go. There's the remnants of it, the remainder. And again, it's something you don't see every day.
I pulled it off the drill bit so you can kind of see it next to the bit itself. I think that's pretty cool.
All right, there it is. Whoops, focus. That looks right. That's not such a small hole in there. You can kind of get a 3D version, or view rather, of that hole in there. In other words, you can kind of see the depth of it in the shadow. We'll do the peekaboo test, and if we don't have a plug in there, see that's where that plug goes. I'm going to talk about that here in a second. We put a light right there and you can really see it good. dead nuts in the center. Nice and round and cleaned out. Alright, I'm going to show you something here regarding these plugs that go into this circuit right there, the one I was just talking about. This is the carb I blew out on the Valkyrie that I ended up doing all that funky Keihin Magna machining on just to see if I could. And then we spaced out the 3 little holes and got all those back in just like it's supposed to be, except reversed. Now these carbs look very similar, if not identical, but they're not. They're different numbers, and they're close. Of course, this is a Valkyrie, so it's got this thing off the back end. This one's from a Magna, so it doesn't, because they mount different. But I believe the carb innards are basically the same. This one's got a much bigger pressed-in jet. That's a, yeah, this is a 3.8. I meant seat, the seat for the float. This is a 3.8 float seat Magna. And this is a 2.6 or 2.8, whatever that says, 2.8 on the Valkyrie. Other than that, like I said, I believe that the casting parts of this carburetor are identical, if not very close to being identical. Now, I'm just showing you that because remember when we did this one in that video, I remember saying when I was drilling this original plug out, I'm thinking to myself going, man, this is a deep plug.
That's a deep plug. I'm not sure where that goes.
And it turned out that it wasn't, or allegedly it wasn't.
Well, it turns out that plug was pretty deep. Now I'll show you what it looked like before I turned that one into chips.
My impression or my assumption was, like this plug is right there, that the plug was simply like a 5 mil and that's it. Just in other words, a flat plug. I'm thinking that the plug basically looks like this. And you put it into the hole. And there's a step in here, or a shoulder I should say, a little shoulder. You can kind of see it at an angle. You see that shoulder? Not the first one, but the second one down deep, the larger one, where that plug sits. So you push it down, that's probably about 5 mil as well. So it goes into the hole, and it seats on that little shoulder. Bob's your uncle, it's done. When I drilled this one out, I was extra careful when I took it out. That is not the case that it has just a flat plug in there. So let me flip this over and show you what I mean, because I've got a drawing going. Whoops, didn't mean to hit you in the face. Here's the parts that came out. I'll zoom up on these here in a second. I'm only showing you this in case you need to do this on a carburetor. You need to know what you're drilling into. Just like on the last video I said you need to look at a jet when you're drilling a jet out because you need to know what you're drilling into. These are the parts that came out. Now I saw this separate from this when I was drilling it through. And I thought it was just a little flat disc. You know, when you plunge through metal and you get that little disc that comes out from the end of the drill, whether it's 118 inclusive angle or another one, you get a little disc as it pushes through. That's what it looked like when I'm looking down at it like this. But if I turn sideways, you see that it is not. It's a plug. It's a small plug, much smaller than this. It's much smaller than that hole down in there. In other words, just above those 3 little holes, the transition holes. So this plug, my friends, is supposed to look like this. And I think it's the same for these carburetors that I'm working on right now, and probably the Valkyries like this one. So that plug is incorrect, which I'm not going to change because it was a project, like an experimentation project. So if I line these guys up like this, which is not going to be the easiest thing to do here, it originally looked like this, with this side going down in deeper, and this is the side that's pressed in. And again, there's clearance for this smaller part of the hole inside that deeper hole because I dropped it in. In fact, I'll do that for you right now so you can see what I'm talking about, because again, I want you to know what's down in here in case you're going to do this. There we go. So with that laying in where it was, you can see it moves around, so it's smaller than that. And it doesn't touch the surface of the aluminum, so it's above that aluminum by a certain amount. So this, I don't know what the purpose of it is. Obviously that clearance is so the fuel and air mixture can get by it. But I want to show you what that plug looked like. Because if you're going to make one, these are the dimensions I came up with in Imperial. Based on measuring this stuff, even though there's some of it gone from the machining or drilling process, it's close enough. And you want to do a screenshot and do your own drawing, go ahead. So I'm just trying to help you out. So off camera I need to make one of these because I'm not going to do any more filming on this carb It's getting really, really hot out here. I may not even do it today. But once I machine this plug out of bronze and reinstall it with little Loctite 638, this thing going to be totally done. And I think that those dimensions are going to be good. Success again. So we're batting, with the we're not batting 2,000. We're batting about 1,500 because of this guy. But for the most part, we have a high batting average right now. Let's keep it that way. All right, so that's it. Hope you enjoyed. Hope you got something out of it. I learned a lot from this one, and I learned a lot from the other carb restoration videos that I've done as far as drilling stuff out. And the stuff I learned from that original Valkyrie carb that I allegedly destroyed helped me fix this one because I knew not to go too deep into that plug. But I also know now why it seems so deep in the first place, because of that little narrower or smaller diameter extension section that goes down in there. Now, speaking of that, those dimensions on that drawing are only estimates because I turned part of that plug to chips. So I'm really only going off what I got. I can definitely get good diameters, but I'm not sure about the depths of each one of those different diameters. If you happen to have one of those plugs that you successfully removed, perhaps using a screw extractor, and didn't turn 3/4 of it into chips, I'd be happy to see that and see the dimensions of it exactly. Then I can modify my drawing accordingly. If none exists, I think you can go off those numbers and make your own plug if you had to do something like that. Install it and be fine with it. That carburetor is not here. I forgot to film any, as far as finished product with the plug installed. I just forgot to do it. Doesn't matter anyway because it's done. It's all in shipment going back to the viewer subscriber. I'm confident it's going to work good. So stick around for some more content because it has not escaped me that we have just crossed the 10K subscriber mark. I wanted to thank everybody for their subscriptions, their viewership, their loyalty to the channel. It really means a tremendous amount to this guy here, okay? We'll be doing some sort of a celebratory video, some sort of giveaway or something in the near future. Until then, stick around. Thanks for watching. And as always, don't just repair, restore. We'll catch you on the next video.